Traditional graphic user interfaces are mainly designed for a single computer. When we use two or more computers, we have to change the operation style significantly. Instead of directly manipulating objects, we have to deal with symbolic concepts such as network addresses. This video demonstrates several new interaction techniques that seamlessly integrate multiple computers. Pick and drop is a direct manipulation interaction technique, extending the concept of drag and drop for multiple computing environments. Using this technique, a user first picks up an icon from a computer display by tapping it, and then lifts the pen tip from the screen. After this operation, the pen virtually holds the object. To drop it, the user taps the screen again. When the pen tip comes close enough to the screen, a virtual shadow of the icon appears on the screen as visual feedback, showing that the pen is carrying the data. The same operation can be used to transfer data from one computer to another. Just like traditional chopsticks can be used to move items from one place to another, the user can physically pick up data from one computer and drop it on another one. This technique can be used to exchange data among nearby computers. Users can use their natural ability to physically recognize a computer and pick up data from the screen. Each pen is assigned a unique pen ID, and the network server manages the binding of pen IDs and carried data so that multiple users can simultaneously perform pick and drop operations. Pick and drop can also be used with digital whiteboard systems. We use an interaction style which is similar to a traditional oil painter's working style, using canvas and palette. In this example, the user has a handheld computer as a tool palette for the whiteboard. The user can select brush attributes, such as color or paint style, or select a picture and pick and drop it on the whiteboard. The same pen can be used to operate the palette and the whiteboard computers. When two or more participants collaborate in front of the whiteboard, a handheld palette serves as a personal workspace for each participant. Each can maintain individual pen attributes, create data, or search for data on the handheld palette, and then transfer it to the whiteboard. This technique is particularly useful for giving a lecture or a presentation. A presenter can dynamically select an item on the palette computer and pick and drop it on the whiteboard. He can also quickly construct a simulation environment by attaching active objects. Palm-top computers, such as a Palm Pilot, can also be used in this environment. A user manipulates a Palm Pilot with a position sensor to select and attach data on the whiteboard. The user can also manipulate items on the whiteboard through the palm-top computer. Pen taps on the pilot affect the objects on the whiteboard. By extending the concept of pick and drop, we have constructed a collaboration environment consisting of a digital table and a digital wall. In this environment, when participants bring their own notebook computers, a video camera mounted above the table recognizes them and their positions by reading attached visual markers. As a result of recognition, the table surface becomes an extended workplace for each notebook computer. For example, the technique called hyper-dragging allows a user to seamlessly drag an object across the boundaries of the computer displays. When the cursor jumps to the table surface, a line is projected to show a connection between the cursor and the notebook computer. The user can also move data from the tabletop to the wall screen. We can pick and drop by using a laser pointer. We call this pick and beam. Physical objects, such as notebooks or VCR tapes, can also be a part of this environment. The user can drag a digital picture to the physical booklet to make a binding between them. Then, the user can move digital data by moving physical objects. In sample application, users are simulating the layout of furniture on the table. Participants can search for a furniture model name on their notebook computers, then drag it onto the table. They can also use a paper furniture catalog and directly drag a piece of furniture from the page. Finally, a mock-up camera is used to inspect the results of the layout. A VRML model is dynamically created and displayed on the wall display in accordance with the current position and orientation of the mock-up camera. We have demonstrated several interaction techniques that can go beyond a single computer on a desktop. We believe that direct manipulation techniques, such as drag and drop, can be extended into a physical environment, and that these techniques can seamlessly integrate single and multiple computer user interfaces.